Today we are going to cover DFS. So DFS, what is DFS, how it works, how it compared with BFS, and applicability of DFS in our day-to-day life. So in my previous videos I have explained knowledge graph, what is knowledge graph, and how we can do traversal through BFS on that knowledge graph. Now that this particular video is in continuation of that series, so now here we are going to understand about DFS. So DFS is a traversal algorithm. So when we have the knowledge graph, we want to traverse over it. So we have list of algorithm. DFS is one of them. So it used for traversing through the knowledge graph. And how it works? It works on a data structure principle, that is the FILO. So that is first in and last out. So we will see in detail what exactly this means, and we will also understand what is when it compared with BFS, where it stands out or what are the similarities among them. And then we will see what is the applicability of DFS in our day-to-day life. Is there anywhere else it is being used which we are not aware of? So let's first understand about this DFS thing. So consider you have a knowledge graph like this. You have 6 node knowledge graph, that is A, B, C, D, E, F, and you want to do a traversal on this knowledge graph using DFS technique. So how DFS is different from BFS? So in BFS, when you do the traversal, you go the traversal like this. You do go for this, and then you go for this, you go for this, then you go for this, and then you go for this, and then you go for this. This is BFS. So you go level by level. So you go to this level, you go to this level, and then you go to this level. DFS works opposite. So how it works out is that when we do the DFS, so in DFS, first it will go to this node, it will pick this one, then it will go to this one, and now it will not go to C, it will go to the depth. So it will start from A, it goes to B, and then it goes to D. So this is the depth first search. So it starts from a node and goes to the depth of that particular node, or the path in that where that path lies, where that path directs, it goes till the last end of the node. So let's understand this concept through this FILO algorithm. So first in last out. So as per this diagram, let's consider this stacks, and the first entry to go inside is A. Okay, so now A went inside stack, and A goes to B and C, but alphabetically B comes first. So the next node which will go inside that stack is B. So A is already there, now B is also present here. Now B goes to D and E, but alphabetically D comes first, so it goes to D. So now D comes inside this stack. So now you have DBA, and this is the first depth of a path which starts from node A. Now D here becomes a dead end, so that means we cannot go beyond this. So what was the last node which went in? That is D. So now D will go out. Okay, what remain inside is still B and A. Now when it backtrack after D is out, it backtrack to here B and check if B is a dead end, but B is not a dead end because there is another path going from B, that is E. So the node now which comes in inside is EBA, while D is outside. So D is outside. Now when it comes to E, it found that E is also a dead end. So basically it came here, and then it found that E is also dead end. Now it will backtrack again, and it will go to B. So now the things which go out will be D, E. So it goes, now what's remaining is B and A. It will backtrack to B. Now B is a dead end because everything is already covered, so it will go to B is also go out, so we have D, E, B, but uh, A still have the possibility of C because A have not exploded C, so C comes in. Okay, so now we have C and A. Now C is not a dead end, so what goes after C is F, so F now comes in. So this is F, C, A, and you have outside D, E, B. Now F is a dead end. If you see here, F is a dead end, so F is have to go out, so it will go D, E, B, F, and now remains is C and A. C is also a dead end now because there is nothing left to be explored, so C is also will go out, D, E, B, F, C, A. Now what left? A has already visited all the nodes now, so A, which was first in, now it's going to be the last out, so that's why now the node would be D, E, B, F, C, A, and this would be empty, the stack would be empty. So that's why it's that's how this FILO works in the DFS, and that's how it goes to all the depth. And it also, if something is not the way it is going in is the same way it backtrack and goes out. So if you see here, it goes through A, B, D, then it backtracked and came from D to B, and then it went to E. Okay, so it does the backtracking and it goes to the maximum depth. So this is the quality of this particular traversal algorithm, DFS. Now when we compare it with BFS, so if we talk about data structure, BFS works on FIFO, that is first in first out, and DFS work on FILO, that is first in last out. If we consider time and space complexity, both have the same time and space complexity. So this is the time complexity. This is for BFS is OV plus E, and similar is the case for OV plus E for DFS as well. And the space complexity is O to the V, and this also is O to the V. So this space complexity is also similar. Just to like simplify, V is equal to, V means nodes, so as many nodes are there, that many operation would be, and that many memory space would be required. And E would be the edges or relationship, so this stands for E, and O is equal to operation. So in my BFS video I have explained how to calculate this time and space complexity. You can go and check there. Now what is the applicability of DFS? So where DFS is being used and we might even not aware. So in our computer systems we want to search any file, right? So that uses DFS. So it goes inside a folder, subfolder, and then files, and backtrack itself, and then it goes to the next folder, subfolder, and try to find the files and backtrack itself. So this way the files we search is coming through the DFS only. Similarly way it also used to solve the Sudoku puzzle, where it can go to the maximum depth until it hits the block, and then it will come backtrack itself and come try to find another path. So that is where it is also used. Another is like, for example, if you are looking for some routes and alternative routes to explore, so you can use DFS to find some other routes as well, which possibly may or may not reach to your destination, but at least you will have something to explore. So this is the way DFS is being used. Thanks for watching.